My name is Nakazu Solome, presenting to you an AI project titled Timetable Generator. And during this presentation, we are going to cover heat maps, correlation matrices, box plots, featured independency plots, outlier plots, illustration of patterns of interest, illustration of trends in time and space, explore and clean data, split data into train, validation, and test sets, fitting a model, hyperparameter tuning, evaluate on validation sets. And heat maps are graphical presentation of data that utilize color-coded systems. The primary purpose of heat maps is to better visualize the volume of locations, events within a dataset, and assist in directing viewers towards area of data visualization that matter most. So here there is a heat map whereby it shows a correlation between the integer values that are in our data set. So the student ID, in correlation with the student ID, it's a one correlation. The correlation is one because they are corresponding, they have the same data, and then we are having the correlation between the student ID and the course ID. It's a negative correlation, and the correlation between the student ID and the year semester, it's a weak correlation. So the correlation matrix, here is our correlation matrix. So we made a correlation matrix for mainly the student ID, and these are the results of the correlation matrix for the student ID. So the box plots, a box plot is a standardized way of displaying the data set based on the minimum, the maximum, the sample median, and the first and the third quarters. So here is a correlation between the days of the week, the attendance days, and the student's ID. So on Monday, many students attended, and the correlation was high. On Tuesday, the same. On Thursday, on Wednesday, and on Saturday, the number of students that attended were few. That's why the box plot is low. On Friday, there are many, and on Saturday, few of them attended, so it was really low. And the feature dependence plots, this show the feature dependencies, like how this feature dependence shows how the students were attending in week, the number of students attending, the relation between the number of students attending in a week in a certain year. So this green color represents year semester, like the number of students that were attending in a year, in a week in a year. So it's high. And then this pink color represents the course ID, the courses that were done every week in a week. And then the yellow represents the student ID, the students that were attending in a week. So the outlier plots, an outlier for a scatter plot is the point or points that are farthest from the regression line. There is at least one outlier on a scatter plot in most cases, and there is usually only one outlier. Note that outliers for a scatter plot are very different from outlier for a box plot. So even as we have one outlier, and this outlier was plotted based on the student ID, and the number of students This outlier is concerning the student ID and the course ID. There are certain students that don't do certain courses. So those students that are in the same year, but they're not doing the same courses are the outliers. And there are these ones that exist as a one outlier. But those that are doing the same courses in the same year, the relationship is shown there. And illustrating the patterns of interest, this was plotted based on the student ID. The relationship between the student ID and the year semester is this, and the relation between the student ID and the course ID. So that's the patterns of interest. And illustration of trends in time and space. As you can see, this orange color represents the year semester and the blue color represents the student ID. So the year semester and the student ID, they have the same maximum because in a certain year, there are certain students that attend, so they have the same maximum, but for the course ID, it changes. The maximum is high because certain courses may be introduced in a certain year, like in different years. But the number of students, they correspond with a year. In a certain year, there are certain students, but the course IDs, they may increase. So how to build an end-to-end machine learning pipeline? A machine learning pipeline helps automate machine learning workflows by processing and integrating data sets into a model, which can then be evaluated and delivered. A well-built pipeline helps in the flexibility of the model implementation and below are the stages followed: data ingestion, data processing, data splitting, model training, model evaluation, model deployment, monitoring, and model performance. Explore and cleaning data. In data cleaning here, we managed to clean our data and remove the missing information. As you can see, data splitting. Data, you may have a set of data that you need to split it into the train and then test part. And the train part, you can again split it into the validation. So this is the length of our data set. This is the data in our data set. And then, so we decided to split it into training and testing. So the training part, we decided to take 30% of the data for testing and the remaining 70% for training. So the 70% was again reduced, like removed 15% for validation set. Splitting data. Here we split our data into parts, one for training our model and the other for testing to see if it can yield the desired results for its evaluation. Fitting any model of our choice. Model fitting is a measure of how well a machine learning model generalizes to similar data to that on which it was trained. A model that is well fitted produces more accurate outcomes. A model that is overfitted matches the data too closely. A model that is underfitted doesn't match closely enough. If your model doesn't fit your data correctly, the outcomes it produces will not be accurate enough to be useful for practical decision making. A properly fitted model has hyperparameters that capture the complex relationships between known variables and the target variable, allowing it to find relevant insight or make accurate predictions. Fitting is an automatic process that makes sure your machine learning models have the individual parameters best suited to solve your specific real-world business problem with a high level of accuracy. Hyperparameter tuning. Hyperparameter tuning is an essential part of controlling the behavior of a machine learning model. Hyperparameter tuning consists of finding a set of optimal hyperparameter values for a learning algorithm while applying this optimized algorithm to any dataset. That combination of hyperparameter maximizes the model's performance, minimizing a predefined loss function to produce better results with fewer errors. And then evaluating on validated set. A machine learning pipeline helps automate machine learning workflows by processing and integrating data sets into a model which can then be evaluated and delivered. A well-built pipeline helps in the flexibility of the model implementation. This is my presentation. Thank you. You can subscribe. Thank you.